So it's 12:15 and I think we should get started. Welcome to this session, to this lunch session about Go, and I'm really astonished how many people found their way in this rather Microsoft-centric conference to this talk about Go. I would like to spend the next 60 minutes showing you only a few slides at the beginning to do some expectation management so you know what you are going to see, and then we spend most of the time for the upcoming 60 minutes in Visual Studio Code taking a look at writing Go code, experimenting with it, running it in Docker containers, in the browser, on the server, and learning a little bit about the language. So my goal in this session is first to make you understand a little bit about the basic ideas, about the philosophy behind the language. What makes Go special? If you are a C# developer, why should you take a look at Go? What's so different about this language? Next, I would like to get you excited. I would like you to leave this room and say, okay, this could be a really useful new tool in my tool belt for building the next few microservices. I do not want to convince you that you should put away all of your C# stuff. I love C#. I do a lot of C# development, but I really think that Go is a cool tool that you can use, especially if you work in the area of microservices. And last but not least, I would like to give you some ideas how your personal journey towards Go could look like. Where can you find more information? What should you do next? What are interesting resources that you can take a look at? These are the three areas which I like to explore together with you in the upcoming hour. Good. Let's get started with the question, what is so special about Go? My personal journey towards Go started approximately a year ago. Last year, I thought about what should I do in the next year. I do a lot of C# development, do a lot of TypeScript development, work as a kind of full-stack developer, and I thought I would like to take a look at something new, something exciting. And then I work a lot with Docker. Docker is written in Go. Sounds interesting. Docker has become the 13th most popular development technology in the Stack Overflow survey, and with that, they are in front of languages like Kotlin, Swift, or Dart. That raised my interest. Even more, it is the 9th most loved developer technology, even in front of C#. That raised my interest even more. Go is compiled to native code. And for me, as a C# and TypeScript developer, compiling code to an executable always looks like this. You take the source code, and the result is a lot of files. Dozens, hundreds of DLLs that I have to ship. Node modules, oh my god. And when I took a look at Go for the first time, I took my application, compiled it, and the result was a single executable with no dependencies at all. You can run it on any Windows machine. You can run it on Linux if you cross-compile to Linux. I will show you how to do that. You can run it directly on top of the Linux kernel. You don't need any runtime installed. A single executable, even for a complex application. That even more raised my interest. And I took a look at Go, and I would like to show you a little bit about the results in the upcoming hour. So what is the basic philosophy of Go? If you just take a look at the language features from the viewpoint of a C# developer, you might be a little bit disappointed when you discover the first steps towards Go. So first we have to understand what's the philosophy behind this language. One of the most important topics is keeping it simple. In contrast to other languages, new features are only added to Go if they really solve a problem that couldn't have been solved before. We don't add syntactic sugar so that code just looks cooler. Think about C#, expression-bodied members. We don't really need that. We can write code without expression-bodied members. Does plus and minus really have to be expressions? They could be statements too. I know, then you can't write if bracket plus I greater than something. We can write that in 2 lines. The idea of Go is to keep things simple. Go has just 25 keywords. That's all. C# has over 100. Go, the next idea is, in Go you don't have to be clever. Well, you have to be clever concerning your domain, but you shouldn't be clever concerning the platform. Let me show you one link here that I have here. Let me click on that one. That's the documentation of the Go memory model. And let me point out this one. I'll read it for you if you can't read it at the back of the room. If you must read the rest of this document to understand the behavior of your program, you are being too clever. Don't be clever. That's one of the basic ideas of Go. It shouldn't matter for you how it works behind the scenes. Can you remember about C# with this whole stack and heap stuff, where you have to distinguish between structs and classes, and when is something on the stack, when is something on the heap, and then we have boxing and closures, and. We must understand that in order to understand our programs. With Go, that shouldn't be necessary. There is no statement about stack or heap because the language handles these details for you. If you would like to contribute to the language, well, of course, then you have to understand the details, but as a user of the language, it shouldn't be necessary to be clever. It should be simple and consistent. I don't know why my notebook keeps making interesting sounds. I just turned that. Do you hear that too? Yeah? I just turned off the sound and it's still. Maybe it's the laptop down there. I have really no idea. Please ignore this strange sound in the background. I'm very sorry. It's not coming from my machine here. Good. Next one. Besides keeping code simple and you don't need to be too clever, your code must be consistent. You see, when I wrote my first Go program, I accidentally called a method with an uppercase letter. And in Go, just to tell you something, if you call a method, begin a method name with an uppercase letter, it's automatically exported as a public method. And I forgot to write the comment on top of it, and so I got a warning. So I was looking for something like a linter or something like an analysis settings file where I can turn off the need to write documentation, and I found out there is none. There is no configuration about linter, about code formatting. There is no question about whether there should be a semicolon at the end of the line or there should be brackets around an expression. It simply cannot be set. Every code in Go should always look the same, independent of who wrote it. If you take Go from GitHub, it will look exactly as your Go code because you cannot configure it. No discussions about whether you want to configure this formatting like this or that. It's simply defined by the community and defined through an open design process of the language. That's another one. Keep code consistent. Is this just because it's young? Well, Go isn't that young, it turns out. It was invented, it came out, the first version in 2009, and we are not even in version 2. So it's kind of baked into the language genes. The Go designers always wait between complexity and adding features. If they add a new feature, there has to be a real value as soon as it starts raising complexity. So keeping the complexity low is a design goal of the language Go. There is an open discussion process on GitHub, so you can contribute. You can also experience and learn together with the team, and the development is relatively slow. So we are currently at 1 point something, and the design process for 2.x has just begun. There is also a promise of compatibility, and that's important if you work in a microservice world where you build your code today and you want to run it on a longer term. Go has a very strong promise of compatibility to make your code consistent, easy to read, and long-term maintainable. Good. That all comes with a drawback too. It has some limitations. Let me quickly ask, excuse me, in the back of the room, the lady just is going out. Okay, when she comes in, I will ask her because, yeah, there is a laptop standing down there and it makes this funny sound. So should I turn it off? Should I try it? I don't know what's happening with the screen. I will try it, okay? We still have picture and it's silent. Oh my God, very good. Good. There are some drawbacks. Limitations. No classes. You're used to classes in TypeScript, C#, sorry. Go doesn't have classes. No object orientation, I will show you how to work around that. No generics. Oh my God, no generics? Yes, you can program without generics, turns out. No try-catch. Oh my God, it's getting really strange, really. How does error handling work if you don't have a try-catch statement? I will show you that in a second. No binary-only packages. There are no object files, no DLLs, no libraries. You always compile everything from source code. Do you want to use a public library? You know where you get it from? Your source code management system, like for instance GitHub. This is your package manager, GitHub, or your private Git server in your company. This is your package manager. ++ is a statement. No if ++i, it simply doesn't work. And you know what? When I looked first at Go, this really blew my mind. So what? This will be the last slide, and then we'll take a look at the code. Go encourages you to stop writing overly smart code. Code should be easy to read, easy to maintain, consistent even across organizational boundaries. Go only improves where it makes sense. Not too fast, avoid syntactic sugar. If you have to write 2 lines instead of 1, that's fine. Just write the 2 lines. We don't want to have overcomplicated code. And Go has a sweet spot for microservices, DevOps, command line tools, and backends. Yes, you can use it for front-end development too, but that is the exception of the rule. So, for me, that's a kind of coding detox. I live in a world with TypeScript and Angular and React and C# and .NET Core, and every day I get a new package and a new version of a language. With Go, everything is much slower and much more relaxed. And in a world of microservices, where you work today on this microservice and maybe tomorrow on another microservice, that's really a value. This is the reason why Go is so popular in that area, because it's easy to switch between microservices, between projects. And with that, let's go in Visual Studio Code, and the rest of we have 15 minutes left. You will only see code, and we will explore the language together. Good. I have Visual Studio Code here. It's my favorite development environment. Maybe you use it too, and I will stay in this area here. I have some notes here, so I will keep my slides up. And the first one, I would like to show you how to start with a Go application. The first thing that you do in a Go application, you call the Go mod init. That's rather new. The module system of Go is rather new and rather young. It creates a module file. You can see it here, where Go writes down all the dependencies. Who would say he or she is a C# developer in the room? Most of you. TypeScript? A few. Okay. For the TypeScript developers, that's package.json. For the C# developers, that is the file where your NuGet references go. Okay. This is the Go modules file. So with that, we can make a folder, a Go application. Next, let's create a very simple Go application. I will call it main.go, and I have prepared a snippet, this one, and we will quickly take a look at the code here. Let me zoom in a little bit. As you can see here, the package has a name. Okay, you can guess that. Then we have a bunch of imports, just like C# usings. I will do many comparisons to C# because most of you are C# developers. As you can see, I'm importing a default package, which is built-in format, and I'm importing 2 packages from a package manager. And guess where Go gets it from? GitHub. It's downloading these libraries from GitHub based on labels which represent the versions of these packages. As I said, there are no libraries, no DLLs, no binary-only packages. That's an important one, because then the compiler can optimize the source code of all libraries when building the application, and can immediately remove that code or do kind of tree shaking and create really efficient code. Okay? So you have to share source if you would like to share some libraries, for instance. And last but not least, a main function. Okay, we know what a main function is, and maybe you get curious about this one. You know, I originally learned programming with Pascal. Anyone used Pascal in the past? Okay, so I found myself back in the 90s somewhere. This is an assign and declare operator. So the variable is declared and assigned in a single statement. And don't wonder about this underscore here. We'll talk about that later on. Essentially, this prints an ASCII art hello world. This is what this stuff does. So next one, let's run this guy. So go run dot, and it will say, okay, I don't have this library installed. Let's go to GitHub, you see it here, and fetch it from there. It installed the library from GitHub in a central folder on my laptop. It extended the mod file, as you can see it here. Now we have a reference to this package. And finally, it executed the code, hello world. Really nice. You want to debug it? Works really good. Just click on the debugger here, add a configuration for Go. You see, launch, Go, blah, and you can immediately run it with F5 if you want. I will not do that here because we only have limited time. Good. Fine? Nice. Now, if we want to build an executable, we can do that. We can just say go build, and optionally we can choose a build target. Let's call it demo.exe. And as a result, we should get, as you can see here, a demo.exe. And the important thing is, what I would like to take away from here, you always get a single exe. I'm adding here a bunch of libraries from GitHub, and still the result is a single executable. Do you want to add some C or C++ code? One of the most important things in Go is that it has really, really nice C and C++ interoperability. And if you do that, the Go compiler will compile your C code, and it will embed the entire resulting code into your executable. No libraries, no dynamic linking, nothing like that. Yes, there are kind of modules. They are called plugins, but we will not go into that, and that's really a not so often used mechanism. The default is single executable. And of course, we can run that guy, demo.exe. Here it is, and it will say hello world. Really, really simple. We can ship that, and it will run on any Windows system. We don't need any prerequisites. Next one, let's do some cross-compiling. Let me quickly copy a few lines. We are still in Windows here. Oops. We are still in Windows, but this time I'm setting a bunch of environment variables. You see what I did here? I created operating system Linux and architecture AMD 64, and I called build, but this time without the extension .exe. Guess what I get? I get a Linux executable, a single Linux executable. You can find it here. So let's quickly spin up a bash on Linux and call it demo. And it runs. Compiled on Windows, created a single executable, I can ship it. You know what we have to install on a Linux machine to run this? Nothing. It runs directly on top of the kernel. You don't need any prerequisites. Everything is baked into this single executable. I loved that when I first saw that. Think of how easy the deployment will be of your microservices, for instance. No need to deploy some framework-dependent or self-dependent executables and think about that. It's a single executable. Good. Now what about Docker? Let's create a Docker file. In our folder, I will create a Docker file. And in this Docker file, I have a snippet for that. We are going to call go build. See it here? This is the go build with a bunch of flags. Don't matter now. I'm creating a Linux executable. And for building the Go application, I use the ready-made image from Docker Hub provided from the Go community, as you can see here. This is called, if you're not that familiar with with Docker, this is called a multi-step Docker file, because we are building it in this step, and down there we are building the real executable for our microservice. Let's call it a microservice here. So the stuff up here, this is the build stuff. And the stuff down there, this is the execute stuff. This is the thing that we deploy in our Kubernetes cluster or wherever we want to go. And as you can see here, we don't need any prerequisites there. We just use a very tiny Alpine Linux, and we copy our application into this Alpine Linux, and that's it. We don't need to do anything more. Let's give it a try. So let's build this guy. I have the line here. Let me copy this one. Good. I prepared that one. It should be pretty fast. Give it a second. The Go compiler is now running inside the first step. This is the Golang Go build statement. And yeah, I'm not connected to, I need to restart Docker. As you maybe know, Docker is a little bit of a diva when it comes to changing the networks. So my Docker daemon was already running when I came here. I was connected to a different Wi-Fi, and now I connected to another Wi-Fi, and now the Docker daemon says, ooh, I don't know where you are, and you have to restart me, otherwise I will not work. While this is running, I can tell you, here we don't absolutely need Alpine. In a second, once my Docker has restarted, I will show you that we can even create the Docker image from scratch. We don't need any operating system in a Docker container to run a Go application. Why? Because everything is baked into the single executable. We just need a Linux kernel. So let's see if my Docker is already running. No, it should just be another few seconds. Any questions in the meanwhile? Just will take 30 seconds more. Good. So you know what? We will come back to that one. I don't want to because I changed. It's running. It's done. It's done. Very good. It's done. So let's give it a try. Where is my Docker build statement? Here it is. Let's give it a second try. Much better. See, now it's connected to the internet. Now it can download the packages from GitHub. It's building, it's building, it's building. And once it has generated the executable, we will have, very good, the Hello Go container. Let's give it a try if it really works. So let's call Docker run. This will now run our Hello Go application inside a Docker container, inside an Alpine Linux, and yes, it says Hello World. Exactly what we expected it to do. Now if we say Docker images, Hello Go, we will see that this image is 9.9 megabytes in size. Everything baked in, the entire Alpine Linux plus our Hello World application. Of course, the image size grows, but it only grows with the size of your code. This is the overhead that we have to bring with us. And that's pretty cool. And we can go even further. As I told you, I can say, you know what? Let's not do Alpine. Let's say from scratch. For those of you who are a little bit familiar with Docker, we now say we don't need an operating system at all. We are running bare metal on top of the Linux kernel. Let's remove that one. The copy is OK. Let's remove that one. And that's it. And let's rebuild the Docker image. Yes. Here is the build. Again, let's wait for a few seconds. It's building the executable again, fetching the dependencies from GitHub based on our module file. And in a few seconds, we will have, yes. And now, let's take a look how large it is now. Now, we have a Docker image with a size of 1.88 megabytes. And it still works. So let's give it a try. Let's run it. Where is the run statement? Images, build, images, run. Here is the run statement. And it should still say hello world. And it does. You see? A Docker container, even created from scratch, to prove that with Go, you have a single executable with everything baked in. Of course, in reality, you will probably use something like Alpine Linux for your production environment because it's pretty handy to have something like Alpine Linux in your microservice. But you could go with from scratch, and I just wanted to make a point that we really don't have any dependencies here. If you compare that with C#, for instance, you always need some binary prerequisites, or you need to install the .NET framework on the target machine in order to run it, depending on whether you do self-contained or framework-dependent deployments. We don't need that here. We don't need to build dozens and dozens and dozens of DLLs and copy them all over because it doesn't make any sense. Can you remember where DLLs came from? I'm old enough to remember that time. DLLs came from a time where you had to share some libraries between multiple applications on a Windows machine. Why? Because you didn't have enough disk space and memory in order to load it separately. But now we have microservices. There is no point in sharing parts of your microservice with a different process if every microservice has its own container. You know what I mean? It doesn't make any sense. So we are applying a concept that originated from something that is not relevant anymore. We see this is built for a new world of containers, and it works perfectly fine. For instance, in an Azure Container Service environment, if you build microservices for Kubernetes, for instance. Okay, good, nice. This was the Docker part. We can even go one step further and run our Go application, for instance, in the browser. Let me show you what I mean with that. I can say, this one, it's copied, it was not copied correctly, so I'm now changing the operating system to JavaScript, yes, operating system to JavaScript, the architecture to WebAssembly, and now we can build something like this, modules.wasm, and it will give us, in a second, here, a WebAssembly file, our Go code compiled to WebAssembly that can immediately be run native without any plugin inside the browser. So if you build some business logic for your microservice, for instance, some validation rules for your business objects, and you are building a client-side application and you would like to reuse this business logic on the client side, you can just compile your code, your Go code, to WebAssembly, and immediately you can access this from JavaScript in any browser on any platform, including mobile ones. So we do cross-platform compile towards WebAssembly. I have prepared a more interesting sample about that. Let me quickly open that one. I've written it down, yes, here in the WASM folder. Here it is, open in terminal, exactly. And let me quickly build that guy. I will tell you in a second what I'm doing here now. Nope, it's not that one. I'm in the wrong folder, I'm sorry. Bear with me. So this application solves the 8 queens problem. Any chess player in the room? The 8 queens problem is an algorithm that places 8 queens on a chessboard so that no queen can reach each other. So what it calculates for the 8 queens problem, it calculates 92 solutions in a microsecond or whatever. And it prints out 2 boards as an example. I will not show you the Go code. If you would like to take a look at it, it's on GitHub, you can take a look at it. That's not the point here. The point that I would like to make here is if we compile that guy in a Docker image to get a web server, for instance, okay? I already prepared that one. If we run this guy, let's run it on port 8081 because 8080 is blocked. 8081 is also blocked. What? I see, no. This one. Good. I have to clean up. You see, I've already running some Docker containers. Here it is. Otherwise, I will not be able to show you what I wanted to show. Goodbye. Now we can run it. Good. So let's take a look at 8080, localhost 8080. Okay, and as you can see, now we have exactly the same output of my Go application. This is the WASM target of Go running inside the browser, and I call it from within JavaScript. And we can see that my browser, if I load it again, is really downloading the WebAssembly stuff, as you can see it here, from our web server, and it's just using a little bit of JavaScript to call into the Go code in the browser. So this is a very important information if you are into building microservices, maybe a backend for front-end architecture, and you would like to share existing logic from your Go microservice in your client, Angular, Vue, whatever, then you can do that by compiling towards WebAssembly, and it just works. Okay? So I think this is pretty awesome. We have now seen our Go application running on the server in a Docker container on Windows, on Linux, and inside the browser, and all with a single file. Good? Fair? So I hope this was already a little bit convincing from the point of view of a DevOps engineer. And now we are switching gears and we forget about the compiler targets and Docker environments and where we run this stuff. Now we are, for the rest of the I think we have half an hour left, we will now dive deeper into the language. Now we change our hats. We are no longer a DevOps engineer. We are now a developer who would like to understand how to write code with Go. Good. Let's go back into my main Go application. Looks good. And the first thing that I would like to show you, yes, it's this one. Let's take a look at struts. Good. Let's move it here. And let's see how that works. Please take a look at these 3 data structures here. This is the main building block that you are going to use when you are targeting Go. You are creating struts. Go doesn't have classes. Everything is a struct. And in my case, I'm creating a struct point, a struct rect, and a struct circle. And if you take a look, you see the point is used here, and the point is used here, as you can see, with the radius, nothing special. Okay? I think everybody gets that, correct? No, there is no inheritance. No, you cannot inherit one struct from the other. Struct, for the C# developers, has nothing to do with stack or heap. Go will always figure out automatically whether to create a variable on the stack or on the heap. It does it by doing a so-called escape analysis. So it takes a look at a variable, and if the variable is only used within a function, it will be created on the stack. If the variable is accessed from outside, it will be created on the heap so that many functions or more functions can access this piece of memory. And you don't have to care about it at all. It just works. So no distinguishing like in C# between structs and classes. Go will figure it out. This is how you work with these classes. This is how you create a class, a struct. This is creating an instance of the point struct, initializing it immediately. I think you understand the principle, and down there I'm printing something. Yes, for the C++ guys in the room, that's printf, but don't worry, it's a safe printf. So if you screw something up with a variable parameter list, Go will jump into your face and say, oh, you did something wrong, so you are safe. No C or C++ madness where you create very strange errors. It's really safe. Let's give it a try. I can remove that one, and that one, and let's go into the hello Go folder and into the live folder and say go run dot, and it will print something. Yes, some numbers. Believe me, it really works. These numbers are correct. Good. That was, by the way, you see a warning here? This warning says exported type point should have comment or unexported. Do you want to get rid of that with a setting where you say, hey, I'm currently not interested in writing docs? Sorry, you can't. Either you write docs or you don't export it or live with the warning. That's it. That's the idea of Go. I had some problems coming from the C#, understanding this philosophy, but at the end of the time it was fine. I got used to it, and yeah, you can program like that. Next. Let's replace the point structure with something like this. This is something that looks a little bit strange through the eyes of a C# developer. These are so-called tags. For each element in a struct, you can add tags, and I explicitly took the tag which is relevant for JSON. JSON support in Go, as well as support for gRPC and protocol buffers, protobuf, is really, really very good. It's built into the standard class library, and if you want to build services, either RESTful services or gRPC services or something like this, Go has really built everything you need into its belly, if you want. It comes with a lot of standard support for that stuff, and Google also provides some additional libraries that support protocol buffers and gRPC and many, many other things. And this is an example how you would define how the point structure should be marshaled towards JSON. Next one. Yeah. This is how you marshal something towards JSON. You just say JSON.marshal and give it a point, and the result will be the JSON representation of this point. Let's give it a try. It should now print our numbers and the JSON representation of our point. It's easy as that. Good, next one. Let's add some functions here. So let me zoom in a little bit. No, I will not. Yes, I can zoom in a little bit. Yeah, something like this. This is good. So please remember, we have the rect struct up here. And now take a look at this function. This is how you define a member function in Go. As you can see, the fact that it's a member function of the rectangle is defined here. We are saying the method with is attached to the structure rect by using this syntax. It has a return value, nothing special, and it has an implementation. This is how you add functions. Okay? Easy to understand, right? Not that difficult. Good? Area and so on. However, this one is an interesting one because now we are attaching a function to a pointer to rect. Yes, we can do that in Go. Pointers are a first-class citizen in Go. But don't worry, it's not, again, the C# and the C and C++ pointers. It's safe pointers, it's type safe pointers, but you can think of it more as a reference in C#. So in this case, we are adding a method to a reference. Here, we are adding a method to an instance. The difference is that in the first one up there, we cannot change the content of rect. In the second one, because we have a reference to the rect, we can change the content of the rectangle, as you can see here. That's the big difference. Attaching a function to a reference or attaching a function to an instance. And with that, we can easily create functions which, by design, are just reading data from a rectangle, and the other one is reading and writing data to and from the instance. Get the idea? Huh? Pretty neat. Good. Next one. Yeah, what is if we call some functions? This one, this is how you call a function. It's really trivial. Just call it and that's it. Yeah, it really works. Ah, by the way, have you seen that? No semicolons at the end of the line. Yeah, maybe that hurts some of you who come from the C# world, but believe me, there is a world after semicolons. It's fine. It's fine to let go. So, yeah. By the way, you could write semicolons, but they will be removed because nobody writes them in Go. Good. Interfaces. Interfaces. Let's think about interfaces. Interfaces are another very important thing here. Let's take a look. This is an interface. You see, I defined a shape interface which has an area. The area has to be a function and it has to return float. So now as a C# developer, we could expect that we go to the rectangle here and somehow say this implements the interface shape, but we don't do that in Go. We simply don't need to. Interfaces in Go have a lot of similarities with interfaces in TypeScript. They do structural inheritance. What does that mean? The less formal name for that is duck typing. So if I stand here and say quack, 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 and I ask you what am I, you maybe say you are a duck. Believe me, I'm not inherited from duck. Yeah? But I'm standing here, I'm sounding like a duck, I'm looking like a duck, so let's call him a duck. And this is duck typing. Everything that has a method, which is called area, and returns a float, is from now on called a shape. And you do not explicitly have to say this is a shape. It's just there because it looks like a duck, it walks like a duck, so call it a duck. Get the idea? That's a powerful concept. For those of you who do TypeScript development, you are already used to that because TypeScript works exactly in the same way. Think of C#. You have a team developing a library here and another team developing a library here, and you have a consumer who would like to handle both things identically. What do you need? A common base class library up here where both implement interfaces or derive from in order to have some commonality. In Go, you don't need that. In Go, as an outsider, you can say, this is a duck and this is a duck. As long as they walk equally and sound equally, we call both a duck. And both things don't even know that they are considered ducks. Get the idea? So in my case, let's take a look in area. Here it is. We will find out that we have a function area for rectangles and we have a function area for circles. So without doing anything, we simply now have rectangles and circles which we can consider as shapes. Good? So let's give it a try. So here I'm creating a kind of array, if you want, and I'm adding an array of shapes, and I'm adding a rectangle, and I'm adding a circle, and then I can use a for loop with the range operator. It's something like a for each. So as a C# developer, you can read here for each shape in shapes. But the big thing with the for operator here is we also get an index. Isn't that nice? I would love to have something like this in C#. How often have I skipped the for each loop for a for loop because I needed an index? We don't need that in Go. So we can simply iterate over an array or slice or whatever by using the for range method here. And as you can see, we are using the interface because rect and circles are ducks. They have a method which is called area, and we can call this method area because they implement this interface. Structural subtyping is the formal name of the concept here. Very different from what we know in C#. Get the idea? Good? Good. Next one. Yes, of course, we have constants. I will not talk a lot about them. This one is the thing that I would like to talk about. Please take a look at the colored circle here. The colored circle has something special in it. It has a circle in it. It embeds a circle. And that's the closest thing in Go that you can come to inheritance. So what we say is the colored circle has everything what a circle has plus a color. But it embeds the circle. It doesn't inherit from the circle. You can embed multiple other structures, kind of multi-inheritance, no, not really, but kind of. You can embed other structures. So our colored circle is a circle plus a color. Get the idea? Now, because the colored circle embeds a circle, does it still implement the shape interface? Yes, it does. Because it embeds a circle, therefore it is a circle, therefore we can calculate the area of a colored circle. Get the idea? A little bit different and maybe a little bit strange at the beginning, and yeah, we can add functions to it and still we can apply interfaces to it. Good. Now what can we do with this? We can do interesting things here. Let me create here. I will move that one up here and remove the comment from there. Good. Let's add it to the shape. Just to prove the point, the colored circle, although it embeds the circle, is a shape because it embeds the circle. It still is a kind of duck, if you want. And then let's move this if statement, here it is, into our for loop. So this is reflection in Go. What we here say is, let's take a look at the current shape. We are iterating over the shapes. And with this operator here, with the dot brackets colored, we are asking, is this shape compatible to the interface colored? Therefore, we are asking, does it offer a method getColor? And if it does, we can call it. Get the idea? So you have something like reflection, but in Go, you use it very, very infrequently. In C# we often use reflection to build generic algorithms. In Go, you typically don't do that. In Go, you prefer code generation instead of reflection at runtime. Go has a powerful code generation engine built into its build tools. So typically, you do not do things at runtime, but you do it at compile time. This is also the reason why there currently are no generics. If you need to implement a list of something, and you need to have it for float and ints, then please generate two lists. A list for float and a list for int, and use a compile time construct to generate code. Dependency injection. One of the most important and most widely used dependency injection systems of Go, for instance, they are doing dependency injection at compile time. They are analyzing the dependencies between the objects, and they are really generating the necessary creation code with wiring up the dependencies, not at runtime, because Go is built for performance and efficiency, and we want to avoid using something like reflection at runtime because it slows down our applications. Get the idea? That's a kind of philosophy. You can do something like reflection, but you typically don't use it as frequently as you do in C#, for instance. Got it? I can run it, but believe me, it works. You can try it at home. Yeah, we have the embedded struts. So now we have covered everything about structs. I would like to show you a little bit about pointers. Pointers are a very important thing here in Go. Come on, here we are. Embedded structs, and here we have the pointers. I've created a small package, a small sample application with pointers to show you a bunch of ideas how you work with pointers. This is just a value. I think you get the idea. This gives you the pointer to this memory where you have stored this integer value. And this is how you can dereference the pointer. Okay, this is what gives you the content of the memory that this pointer points to. It's a safe pointer, don't worry. So you cannot change the data type and you cannot do strange pointer arithmetics like in C and C++. It simply works. Now the important thing that I would like to show you, the rest is really understandable. The important thing which is not obvious is this one. I'm creating a type, a struct called person, and I'm getting a pointer to the person. And see how I dereference the elements in this person? I don't need to write any pointer symbol like in C or C++. When I use a pointer, I can still use the dot operator. I don't have to care. Maybe the code shouldn't change depending on whether I have a pointer to something or whether I have an instance of something. The code using this stuff is always using a dot. And this is very convenient. You don't have to always think about, oh, do I have now a reference or a pointer? And if you change it because your algorithm changes, you still have to change the whole code. That's no longer necessary. You can also use pointers for parameters. Go only uses call by value, but you can use pointers as a value. And with that, you get call by reference. Good. Get it? Difficult? No. But it's really useful to understand that you have pointers, because with that you have full control over whether the recipient can change and manipulate the instance that you give him. And on the other hand, you can control how much data is copied on the stack and from a result back from the stack to your calling method. I think you get the idea. Pointers. Error handling. This is kind of strange. Oops, I didn't want to do that. This is kind of strange, but it's really idiomatic Go code that you see here. As a C# developer, this looks really, really strange, but this is so typical. First thing that you should note here, in Go, every method can return multiple return values. That's not a tuple. It's built into the language. You can really return multiple things from a function. And in that case, it is a kind of convention that you always return an error indicator as the last element, as the last return value. So if your method can run into an error, it should return its result and an error. Error is a data type inside of Go, and because I just have 60 minutes, I can't go into the details. It's a very powerful construct, and you can do a lot of things with it. So take a look at the code. If we have an error, we create an error. Yes, you can have advanced error data and so on, but you do not have exceptions, and that is the important thing here. Yes, Go has something for really, really critical exceptions. It's called panicking. So in Go, you can say, I panic because something really bad happened, and the caller can handle the panic and exit gracefully, for instance, but you shouldn't panic if it's just a typical error that can happen. For instance, an error because of parsing a string into an integer or something like this. This is no panic, okay? So the typical error handling in Go looks like that. And if you call this guy, or if you want to call this guy, this one, you do it like that. You call the diff, and then you have the typical if statement here. The philosophy of Go says, if an error can happen, I would like to have the error handling code as near as possible to to the origin of the error. I don't want to have an exception here and 7 calling layers up above I have a try catch statement which handles the error. That is not the idea of Go. Go says put the error handling where the error happened. If I take a look at the code and I'm not sure if this error is really interesting and should be handled, I should immediately see it when I take a look at this code. I don't want to walk up the call hierarchy to find out if somebody handles this exception. That's the idea of Go. This is how error handling in Go works. But pretty different from C#. The last 10 minutes I would like to dedicate to one of the most important concepts of Go. I saved, if you want, the best for last. We are talking about channels and Go routines. Let's add a little bit of code. Come on, give me my snippets. Here they are. And let's add first this one. Please take a look at this code. It has a method which says hello, nothing special. And here we call the method nothing special. But now take a look at that one. This is the language construct that gave the name Go its name. That gave the language Go its name. Go say hello. This Go say hello starts the say hello method on a separate Go routine. What is a Go routine? Is it an operating system thread? No. It's for C# developers, it's kind of a task. Not really. There are major differences, but conceptually you could think of it like a task. Yeah? It is a concept not of the operating system, it is a concept of Go. Go has its own Go routine scheduler. And it will make sure that all your Go routines run nicely side by side. I only have 60 minutes, so I can't go into the details. And if you are interested, I'm sure you will find out the details. But here, for C# developers in the room, you can think task.run. Just go. Go, say hello, Go routine. And then I'm sleeping a little bit in order to make sure that everything is printed out. Understand it? I think understandable. If you are a C# developer, task is nothing very special. That's the start Go routine. But now I can do some crazy stuff. I can create functions, as you can see them here, that get a parameter of type channel of a specific type. What is a channel? A channel is a kind of communication channel between the calling Go routine and the called Go routine. They have a connection. They are not losing the connection. The child Go routine can still talk to its caller through a type-safe channel. You do not need shared memory in order to return some data from the callee to the caller. Get the idea? It kind of smells like async await, right? But the difference between channels and async await is that a channel can receive many, many different results. It's like streaming results from the called Go routine back to the caller. So in my situation, the get value async does some asynchronous thing here. Maybe think of accessing a database or calling a downstream microservice, doing some gRPC stuff or whatever. And as soon as it has a value available, it can send this value through the channel up to the caller so the caller can do something with this value. Get the idea? And this here, it doesn't need to be a simple data type like int. It also can be a complex data type like structures, for instance, and many other things. So how do we handle that? We create a channel using the make statement here. We create a channel and then we can pass the channel into our callee. It receives the channel and it will send me through this channel something back, and this here is now telling Go to wait here until something is available through this channel. It's a kind of a wait statement. Understand what I mean? So the C# developers can read await result. But the big difference is that with this await, we are no longer really limited to one result, but we can stream back results. Are you familiar already with C#8? Have you seen the new feature, await for each? Yeah? Async streaming results, very similar to what we have here. So you see these languages, they influence each other. That's fine because all of them are open source. But it's a kind of influence that comes in here. And as you can see, you can consume the result or you can simply wait. If you have a Boolean channel, you can simply say, wait here until I got a result. And once we have the result, we can continue going on here. Get the idea? So channels are really a very, very powerful concept. And it's kind of unique when you think about it. Let me show you the last two snippets and then we are going to wrap up. I would like to draw your attention to this one. We call our value, and please remember this was the channel stuff. It's returning something through a channel. But now we are using something which doesn't exist in C#. We're using a select statement and we are selectively waiting for multiple channels. What we essentially say is, wait until one of the two channels have a result for me. The first channel will return a result after maybe the downstream microservice call is done. And the second channel is using a library function which says time after, which also produces a channel, and it will send us automatically back a message after 5 milliseconds. So essentially what we do here is we are implementing a timeout method for some I/O operation. Get the idea? And the select is a kind of select case, but with support for channels. C# doesn't have something like this. And this is very, very powerful. Think of microservices that do async, non-blocking I/O with databases, with microservices, with some NoSQL databases, with Azure Cosmos DB or whatever. You will find in many situations code like that where you handle some channels, maybe this one answers or this one answers, and this is typical idiomatic Go code. Get the idea? Good. Now, yes, if we would have more time, this is a slide deck of a longer talk, a longer workshop that I often give. You can take a look at C interoperability. We'll show you in a second where you can find all this material. You can take a look at web APIs. I recently gave a longer talk at the conference about web API basics, and I will also show you a link to the recording here. Before I show you the links here, I would like to cite Joel Spolsky. I think he's the founder of Stack Overflow, and he said something recently in an interview: productivity is best improved by reducing complexity. And this is exactly what I think Go is really good at. You have to write consistent code, code that isn't overly complicated, and code that is easy to read and easy to maintain, and is really focused on building microservices, business logics, and CLIs. This is what Go is really good for. And I think it does a really good job in that area. Can it replace all your C# and TypeScript? Definitely not. Not at all. If you would like to do some client-side development with WPF or so on, hey, go for .NET Core 3. If you would like to, I don't know, reuse your existing .NET stuff, hey, do it. It's fine. .NET is a really good language. But if you want to have a microservice for a Docker environment, then you definitely maybe should take a look at Go, because yeah, it produces pretty efficient code and nice applications. So if you want to know more, what can you do? First, I record this session. So my recording equipment is standing here, so I will put the whole session online so you can go through it again step by step and also use my code snippets. If you would like to take a picture, you can. This is my GitHub repository. If you clone this GitHub repo, open it in Visual Studio Code, you immediately get all the code snippet that I showed you here. So you can really walk through the demos step by step and explore them in more details, for instance, using a debugger. Additionally, I would like to draw your attention to my YouTube channel. It's here. It's absolutely for free. I publish nearly all the talks that I give at conferences, even full workshops. A minority of the talks is in German. Unfortunately, I do a lot of German talking. I'm from Austria, this is the reason, but the majority of the videos are in English. You will find this recording there. You will find other Go talks that go into more details about the WebAssembly stuff, about building web APIs and so on. And I will keep posting videos there. So if you would like, subscribe or just every now and then check the YouTube channel, and maybe you will find something interesting there. If you would like to get in touch with me, that's me, Rainer Stropek. Just go to rainersdropback.me. It's my profile, my virtual business card if you want. And down there, you find some important links like, for instance, LinkedIn and Facebook and Twitter and GitHub and YouTube. And feel free to send me an invitation. I'm more than happy to keep in touch and answer any questions that you have after this talk. I would like to say thank you for coming to this talk, which is rather not typical for a Microsoft-oriented conference, but I still hope that it was valuable and you take some ideas with you. Thank you very much and enjoy the rest of the conference.